Before we begin, slow down. Seriously. Loosen your shoulders, unclench your jaw, grab a coffee, tea, water, or whatever you use to trick your brain into cooperating, and just listen for a while. If you like where this goes, like the video. Leave a comment with your favorite way the universe might end, and share this with someone who enjoys calmly staring into cosmic oblivion. Okay, now, everything you have ever known will end. Not metaphorically, not symbolically, literally. Your phone, this video, Earth, the sun, the Milky Way, time as you understand it. Eventually, the universe itself will reach a state where nothing interesting can ever happen again. And the unsettling part isn't that this will happen, it's that, according to physics, this is the default outcome. So, how does the universe end? Well, it depends on what the universe actually is, and that's where things start getting weird. Let's start with something comforting. Right now, the universe is alive with activity. Stars burn, galaxies collide, particles smash together at absurd energies. Space itself is stretching, carrying galaxies away from each other like dots painted on an inflating balloon. But that expansion is the key, because expansion isn't just movement, it's a slow draining of usable energy. And energy, it turns out, is the currency of existence. To understand the end of the universe, you need to understand entropy. Entropy is often described as disorder, but that's not quite right. Entropy is about options. A low entropy system has many ways to do interesting things. A high entropy system has run out of choices. A fresh battery has low entropy. A dead battery has high entropy. Both still contain energy, but only one can actually do anything. The universe began in an extremely low entropy state, which is strange because low entropy is rare, like finding a perfectly shuffled deck of cards already in numerical order. That improbability is the reason time exists in the direction you experience it. Time moves forward because entropy increases, and entropy has an endgame. The most widely accepted scenario for the end of the universe is called heat death, which sounds dramatic but is actually incredibly boring. In heat death, the universe doesn't explode or collapse, it simply fades, slowly, quietly, relentlessly. Stars burn out, galaxies lose their structure, matter decays, temperature differences disappear. Eventually, everything reaches the same cold, uniform equilibrium. No gradients, no motion, no chemistry, no life, no thought. Just particles drifting in an ever-expanding void, unable to do anything interesting ever again. This is not destruction, it is exhaustion, and it's terrifying precisely because it's so calm. But heat death isn't the only possibility. There's another scenario called the Big Rip. This one is less polite. The universe is expanding, and that expansion is accelerating. Something called dark energy appears to be pushing space apart faster and faster. If that acceleration keeps increasing, there may come a time when the expansion overwhelms all other forces. First, galaxies are torn apart, then solar systems, then planets, then atoms themselves. Eventually, even space-time loses coherence. Everything is ripped apart at every scale. Imagine the universe tearing itself to shreds, not from violence, but from excessive enthusiasm for expansion. Then there's the big crunch. This is the dramatic reversal ending. Expansion slows, stops, and reverses. Gravity wins. The universe collapses back into a hot, dense state, possibly leading to another Big Bang, a cosmic reset button. The problem is that current observations suggest this probably won't happen. Expansion doesn't appear to be slowing down, it's speeding up. So unless something changes dramatically, gravity has already lost this fight. But physics still has a wild card: vacuum decay. This one is unsettling because it could happen at any moment. According to quantum field theory, the vacuum of space might not be in its lowest possible energy state. It could be metastable, balanced on a ledge, comfortable but not permanent. If that's true, then at any moment a tiny region of space could tunnel into a lower energy state. That region would expand at nearly the speed of light, rewriting the laws of physics as it goes. Atoms would no longer hold together. Chemistry would stop working. Forces would change. Reality itself would be replaced with something else. You wouldn't see it coming. You wouldn't feel it. One moment everything exists. The next moment it doesn't. Or rather, it exists in a way that cannot support anything familiar. The universe would end instantly, without warning and without drama. And statistically speaking, this is allowed by physics. Comforting. But let's pause, because all of these endings assume something important, that time continues forever. What if it doesn't? Time might not be infinite. It might be emergent, a property of entropy and change, not a fundamental ingredient of reality. If the universe reaches a state where nothing changes, time itself may stop having meaning. In a universe with no events, no differences, no observers, what does later even mean? Now, here's where things get even stranger. If the universe lasts long enough, even in heat death, quantum randomness allows for absurd events. Given infinite time, particles can fluctuate into ordered structures purely by chance, which means that eventually, random brains could form. Fully conscious entities that exist briefly, experience confusion, and then dissolve back into chaos. These are called Boltzmann brains. And the terrifying implication is that in an infinitely old universe, most observers might be these random, momentary minds. Which raises an uncomfortable question: how do you know you aren't one? Now, zoom out again. The end of the universe might not be a single event. It might be a series of transitions, or part of a larger multiverse, or a small chapter in a reality that spawns universes the way trees drop leaves. Our universe might be one experiment among many, one bubble in an endless foam of space-time, ending not because it failed, but because it finished doing what it was always going to do. And here's the strangest part. From the universe's perspective, none of these endings are tragic. There is no goal the universe fails to achieve, no destiny it falls short of, no expectation it disappoints. The universe does not care if it ends in silence or fireworks. It doesn't care if life persists or vanishes. It doesn't care if meaning evaporates. Meaning is something we invented, which means the end of the universe is only frightening because we are here to imagine it. You are a temporary pocket of low entropy, a small island of order swimming upstream against the current of chaos. You exist because the universe is not yet finished. Every thought you have, every memory, every joke, every fear, every quiet moment staring at the ceiling at night wondering what all of this is for, those things are only possible because the universe is still young enough to allow complexity. You are not separate from the universe. You are what the universe does when it has enough energy left to think. And one day, it won't. But here's the twist. The end of the universe does not rob your life of meaning. It gives it urgency. A book that never ends is unreadable. A story without an ending is noise. The fact that this all stops, eventually, makes what happens now matter. Stars burn because they will burn out. Life exists because it will not last forever. You care because you are finite. The universe will end, almost certainly, in some quiet or catastrophic way. But until then, it is awake, and right now, it's looking at itself through you. So finish your drink. Sit with that thought for a second, and if this made you feel small in the good way, like the universe just gently reminded you that you are part of something vast and temporary and strange, like the video, leave a comment, and share it with someone who enjoys calmly contemplating cosmic endings. Because one day,
everything will stop. But not today.